Hey, what's good, my little balls of anxiety? We are going to talk about the law of sines today. So, at some point, you've probably asked yourself, Mr. Barton, all you've ever taught me how to do is stuff with right triangles. What if the triangle isn't a right triangle? What if it's an oblique triangle, which is a fancy word for a triangle that looks like that? Ooh, that's an ugly triangle. Hold up, try again. Maybe something like that. That would be oblique. You could also have something like that. Anything that isn't a right triangle is an oblique triangle. So not this, anything else. Oblique triangles are all the things that are acute and obtuse triangles. If it's acute or obtuse, it's oblique, right? So we're going to talk about if I have a triangle that isn't a right triangle, how do I find the sides and angles for that triangle, right? Once we have the law of sines, you'll only be missing one more thing, and then the entire kingdom of triangles is at your command. So that's kind of exciting, but anyway, let's talk about what is the law of sines. So the law of sines is this. Let me go ahead and draw a triangle for us to investigate this for. So if we look at this triangle, you can see sine of A, sine of B, sine of C. Capital A, B, and C are our angles. It doesn't matter where you put them, just so long as you put them. So we'll call this capital A, this will be capital B, and this will be capital C. All right, so there are our angles. Lowercase a, b, and c are the sides that are directly across from the matching angle. So side A is directly across from angle A. So if I start at angle A here and I go straight out the middle of that thing, side A is the side that I run into. Likewise, go straight out of the middle of B. The side that you run into is B and C. So what this says is that if I take the side length of A and divide it by the sine of this angle, that will equal the same thing as long as I use either of the other two corresponding side lengths and angles. So as long as you keep A's with A's, B's with B's, C's with C's, any of these ratios are true. So this will let us solve for A, B, or C of either the angle or the side. Cool. Yeah, cool, tight, super sweet. I can't wait for you guys to use this thing. Very powerful. Let me just make a little side note here. You're allowed to flip the law of sines. You could reciprocal all of these, right? Flip them upside down. This is true. So is sine of B over B, equals sine of A over A equals sine of C over C. So if you want, you can put the sines on top and you can put the side lengths on the bottom. Either law of sines is fine. It doesn't really matter. Yeah, there you go. You're good to go. Cool. So let's go ahead and use this thing. All right, cool. Before we use it, though, let me tell you what this thing is good for. So here are the types of problems you're going to want to use the law of sines for. And the observant among you may ask, is there a law of cosines? There is a law of cosines. That's tomorrow. So the law of sines is not good for just every single oblique triangle in the world. The two types that it is good for, or are good for, is good for, are two angles and a side. So if I give you this triangle and I tell you this angle, and this side, law of sines is great for that. The other thing that this is good for is two sides and an angle. So if I tell you this side, and the angle across from one of them, so this one, it would be great for that. If I tell you the angle in the middle, it is not good for that. So luckily, your homework will only be ones that you can probably solve. I'm not going to be like, aha, you can't solve it with law of sines. You need the other one for that. I'm not going to do that to you. But in a second, I'll show you like how you can tell if it's law of sines or not. These two things have something in common when you start plugging in the information that they tell you. So ones that law of sines is not good for are if I just tell you all three sides. I say, here are your side lengths. You cannot find the angles with that information. The reason is this is a similar triangle, and I could just make it, you can kind of like move, it doesn't work. You know what I mean? The other one is the one I mentioned up there, where if I tell you two sides and then the angle in between them, that one also won't work. So the way you can tell if it is solvable with law of sines is if we look at our law of sines, which is this, then something will happen that will let you'll be like, oh, this is definitely solvable. The thing that will happen is one of these three fractions will be completely filled in. So let's take a look at two angles and a side. So if I know two angles, let's say here's A, here's B, here's C, A, B, C, and any side. So let's say I know A, I know B, and let's say I know side C, right? Then we'll have this, and this filled in. You're going to say, wait a second, this doesn't complete a law of sines. This thing, I'm still missing A. This thing, I'm still missing B. And this thing, I'm still missing C. Okay, fair point, but let me show you why that doesn't matter. Let's remember something about triangles. If you have a triangle, these three angles do something special. A plus B plus C equals 180 degrees or pi radians. We're going to do everything in degrees today because it kind of just lends itself to the law of sines. But you could do it in degrees or in radians if you really want. So if I know A and B, even though I don't explicitly tell you C, this equation is so easy to solve, it doesn't matter. And you know C. You know what I mean? You know C. You don't know what the number is, but it's so easy that you might as well, right? So if you know any two angles, you basically know all three angles. And if you have a side, you have to have one of these filled in. The other one that we talked about are two sides and an angle across from them. So if we know, let's say A and B, and the angle across from one of them basically says either angle A or angle B, right? So it guarantees that one of these will be completed, and you'll have like 3 over 0.9, right? It'll be a complete fraction and solvable. So the way you will know, can I use the law of sines, is if you have your law of sines written out, one of these three fractions will be solvable, and you can use your calculator to get it down to one single number. Okay, cool. If it's not possible for you to complete one of these three fractions, what that tells you is that you're going to have to know the law of cosines, and we'll learn that tomorrow. So, all right. So we remembered that A plus B plus C is 180. So let's go ahead and just do some law of sines problems. I have 3 for you, and then a special bonus one. I'm going to try my best not to give you bonus one type questions because they're kind of a pain in the butt and require a little bit of extra thinking. And honestly, you're online and I'm not trying to do that much, right? I'm not trying to make you do that much. If you need it in college, someday you'll learn it. Okay, so let's talk about example one. We have two angles and one side. So we have AAS. Let's go ahead and start by labeling our triangle with A, B, and C, just so that we can plug stuff in and make sure we keep everything straight. So I'm going to call this angle right here, let's call that A. So then this side over here, this is little a. Let's go ahead and call this other angle that we know B. So this big long side here is going to be little b, and then this one will be C that we don't know. So this side is C. All right, so let's just pretend we want to find all the information we don't know. So we want to find angle C. Angle C is equal to what? Lowercase c is equal to what? And lowercase b is equal to whatever, right? So we want to find the missing angle and the two missing sides. All right. Because we know two angles already, this missing angle is so easy for us to find. We're just going to use the fact that A plus B plus C equals 180. We're going to plug in the two angles we know. So we're going to plug in 28.7 plus 102.3 plus C equals 180. 28.7 plus 102.3 is, what is that? 31. 131 plus C equals 180. Subtract 131 from 180. These cancel. C equals 49 degrees. Okay, cool. So now we have all three angles. So if we go ahead and start setting up our law of sines, just so that we can look at it, observe it, see what's interesting about it, and pick what we want to solve for next. We know side A is 27.4. We know angle A is sine of 28.7. Side B is still a mystery, but we have sine of angle B, which is 102.3. Side C is still a mystery, and sine of 49 degrees. So we know we can solve this using the law of sines, because if we look at this angle, or this fraction right here, both the side length and the angle are filled in. So this is a complete fraction that we could plug into our calculator and get a number for. So let's go ahead and solve for, it doesn't matter. Let's go ahead and solve for B. So if we want to find B, what we're going to do is we're going to ignore this chunk of the fraction for right now. We're going to just look at these two fractions with the equals between them. So we're going to have 27.4 over sine of 28.7 degrees equals B over sine of 102.3 degrees. These two signs are just numbers. So what we're going to do is we're going to isolate B by multiplying both sides by sine of 102.3, and then we'll use our calculator to simplify. Okay, so this cancels with this, and we get B equals sine of 102.3 degrees times 27.4 divided by the sine of 28.7 degrees. Okay. Then we're going to go ahead and just plug all of this into our calculator, and it will spit out B for us. So when we plug this in, first thing, make sure your calculator is in degrees because you're using degrees. I already have the answer written down because I didn't want to, make you sit and listen to me type something into a calculator again. Who would do that? So when we do this in our calculator, we get B equals 55.75 degrees. Not degrees, pardon me. Feet, because obviously it's not an angle, it's a length, right? So B is 55.75 feet. Now, if we want C, all we have to do is use this fraction and either of these two fractions. Because we now know this B value, you could plug B into there and use this fraction, but it's not exactly 55.75 feet. I rounded this once I got my calculator. So what you want to do is probably not use this, because if you use a rounded number to get a new number and then round again, this number has effectively been rounded twice, which means you're not going to get as accurate an answer as if you use unrounded numbers. So what we're going to do is we're going to continue to use the A chunk of the equation, and then we'll set that equal to the C chunk, because this number and this number have not been rounded. These are numbers that were given to us in the problem, so they're safe, and we get to assume we know them with perfect accuracy. In real life, probably not, but it's fine. Math isn't always about real life. So all we have to do is repeat this same process, but with the C fraction. So we're going to say 27.4 over the sine of 28.7 equals C over the sine of 49 degrees. We're going to multiply both sides by the sine of 49 degrees. These cancel, and we get that C equals sine of 49 degrees times 27.4 over sine of 28.7 degrees. And when we plug that into our calculator, we get about, this is rounded again, we get about 43.06 feet. And now we know all three side lengths and all three angles of our triangle. So we have solved the triangle. We know everything about it, and there's nothing that's a mystery to us. We have perfect knowledge of the triangle, which is kind of cool. All right. Let's go ahead and look at just another example. This time, instead of giving you the triangle, what I've done is I have just given you some information, and now we're going to plug it into the law of sines just to see what we get. So let's start by setting up our law of sines. So we're going to have A over sine of A, so 22 over sine of 42 degrees, equals B, which is 12, over, we don't know angle B, so we're going to just go ahead and put sine of B, equals C over sine of C. So now we cannot start with solving for C, because if I use the angle and side that I know, the completed section of our law of sines, and I set it equal to this, I have two unknowns. I don't know side length C, and I don't know angle C. So if I have 22 over sine of 42 equals C over sine of C, I have two variables and one equation. This is not solvable. If you want to solve something, you need one equation for every single variable you have. So here we have one equation and two variables. It means you can't solve it. So that means we just have to start our problem with the B section, because we know that side length, so we can use it to find the missing angle. There's only one missing piece of information in this one. So let's go ahead and start by solving for angle B. So we have 22 over sine of 42 degrees equals 12 over sine of capital B. All right. So what we want to do now is we want to solve for sine of B. A handy trick here is instead of trying to like get this thing on the top, is because you can't just divide by 12, right? Then you'll get 1 over sine of B. And we don't want that, right? We want sine of B. So one handy trick that we can use is reciprocal both of these. Just flip them over, and that'll make our whole process a lot easier. So we'll look at sine of 42 degrees over 22 equals sine of B over 12. And then we're going to multiply both sides by 12 to get the sine of B by itself. Okay, so we get 12 sine of 42 degrees over 22 equals sine of B. Once we plug all of these in, we plug this thing into our calculator, and then that will tell us sine of B, right? It'll say, all right, sine of B is approximately 0.3649, right? But this doesn't tell us B yet. You plug this into your calculator, you get this decimal. We don't want sine of B. We want just B. So now what we need to do is we need to do the inverse sine on both sides to get B by itself. So the inverse sine cancels the sine, and we get B equals about 21.41 degrees. So there we go. Now we have our angle B. Wonderful. So let's go ahead and write that down up here. How about B equals 21.41 degrees. So now we know this. Now, this is still missing 2 pieces of information. So if I set it equal to this fraction or this new fraction with the information plugged in, it's still not solvable. So the way you force this to be solvable is we use the fact that all of our angles have to add up to 180 again. So we're going to go ahead and use that piece of information to solve for angle C. And you're going to say, but Mr. Barton, isn't this a rounded number? It is, but we can't avoid it in this case. We have to use that rounded number to get this number. And because we're doing adding and subtracting, it's not as big of a deal as if we were, say, multiplying or doing an inverse trig function. So I'm kind of hand waving, but don't trip too much about it. If you can avoid it, don't use a rounded answer, but we can't here. So we have angle A is 42 plus angle B is 21.41 plus angle C equals 180. So these two added together are 63.41 degrees plus C equals 180. Sorry, this should look like a 0, not a 6. Then we just subtract our 63.41 on both sides. And then we get that C equals, sorry, I just want to check my notes so that I don't tell you the wrong thing, 116.59 degrees. Okay, so here is our missing angle. Now we can use this, and we're going to continue to use A again because if we use B, then we're choosing to use this rounded number when we could use unrounded ones. That's the difference. So we're going to plug in this known angle C, use the A section of the law of sines, and we're going to solve for C. So we are going to have 22 over the sine of 42 degrees equals little c over the sine of 116.59 degrees. We're going to multiply both sides by this sine. These cancel, and then this mess, you throw that into your calculator. When you do that, you should get that C equals 29.40 inches about. And there we go. Now we know everything about that triangle. Wonderful. So let's do one more because it's kind of a weird one, and then I will talk about the bonus question. Okay. The bonus question, we're not actually going to solve the whole thing. I really just kind of want to talk about it, make you aware of it, and then hopefully avoid it for the rest of the class. All right. So third one, this triangle that they're going to try and make us make is not possible. You cannot make it. So let's go ahead and look at it, try it, and see what happens. So let's set up our law of sines first. We'll see that there's a problem, and then I'll do some drawings and show you why. So we have 15 over sine of 85 degrees equals 25 over sine of capital B equals C over sine of C. All right. Now, we have to start with B because it's the only fraction with one missing piece of information. So we're going to just look at this chunk. Because the thing I want is on the bottom, I'm going to go ahead and use that reciprocal trick to just flip this over so that we're a little bit closer to having this solved. So we're going to have sine of 85 degrees over 15 equals sine of B over 25. We're going to multiply both sides by 25. So we get 5 sine of 85 degrees over 3. If I reduce those, these cancel. This equals sine of B. So what we're going to do is we're going to plug this into our calculator, and we'll see why this is a problem. When we plug 5 times sine of 85 degrees over 3 into our calculator, what you get is about 1.660. Okay, let's stop and think about why this is a problem. Sine as a function, y equals sine of x. If you graph this regular plain old sine function, you're going to get this thing. And remember, it has a min and a max of 1 and -1 respectively. So when you say sine of some number equals a number bigger than 1, we're asking, where does this graph touch this line? And the answer is nowhere. So because we get a trig function equals, or a sine equals a number greater than 1, there is no solution to this. And you're going to say, but Mr. Barton, what do you mean there's no solution? Why can't there be a solution to this, right? Maybe it's not obvious because we're not looking at the triangle. So let's go ahead and look at our triangle. So let me clear this. And let's grab a protractor. Is that going to work? Can I move this? I can move it. Okay. So what we want is an angle of about 85 degrees. So let's go. Oh, actually, watch this. Is it going to let me? Yeah, there we go. Okay. So that's 85 degrees. Oh, that's not what I wanted. Spit it out. There we go. Okay. Let's get rid of this. Delete. Here's our angle of 85 degrees. Let's grab a ruler. Now, I'm not going to be able to go all the way to 25, but I can go by fives, right? I could say 5. So let's spin this thing. There we go. Okay. So let's make it 5 long, and we'll say 1 equals 5 units, right? So 1 centimeter equals 5, whatever this is, feet. So we'll go 1, 2, 3, 4, 5. Okay. Now, this is angle A. Oops, that's not what I wanted. Let's move this out of the way. Okay. So this thing is angle A. We don't know what this side is. This is side B. Side A has to be across from side A. So this piece here, this invisible piece I haven't drawn yet, that's side A. So if we draw this, if it's 15, it has to be 3 long. So let's go ahead and draw a little piece that's 3 centimeters long. Okay. Get rid of this now. Delete. So here's my little piece that's 3 long. Angle A has to be 85 degrees. We can't change that. So that means here's side B that makes up part of angle A. This is side C. We can change how long it is, but not the angle between it. I can't bring it closer this way. So if I take this thing and I try and connect it to side C, you can see really obviously that this piece is just not long enough that no matter what angle you put it at, it can never touch this line. It's just not long enough. So it's like me putting out 2 pieces of wood. Say, here's a piece of wood, here's a piece of wood, and then I give you this little stick and I say, finish the triangle. It's too short. It can't reach because I'm not allowed to. Like, these are already nailed together, right? I've already put some reinforcement there. You can't adjust the angle. If we had to, maybe we could like put some more stick on there, but this piece is just not long enough to get from here to anywhere here. So that's what the issue is. So this is an impossible triangle that they're asking you to solve. And you will know that because when you go to solve your law of sines, you'll get sine of an angle equals some number that's greater than 1, right? You'll get like 1.6 or something. As soon as you get sine equals something bigger than 1, you go, oh, sine cannot be bigger than 1. That's just not possible. And then you say, this triangle can't happen. Okay, so there are your examples. You are good to go. We're 33 minutes in. Let me talk about one more thing. I'm going to kind of hand wave it, but I'm going to also not make you solve them. But let's talk about this. There are certain situations in which there are 2 possible solutions. So let's look at our setup here. They tell us that there are 2 triangles. Find it where A equals 12, B equals 31, and angle A is 20.5. So I measured this. This is 20.5. I measured this. This is 31. And then I measured these 2 red lines. These are 12. Just like if one of these red lines is too short, it will never make it from the tip of this line to anywhere on this blue line. There is kind of a happy middle ground where, given this length, there's 2 ways I could put that on the existing angle so that it will work. So there are 2 possible triangles. There's this triangle. That is an ugly triangle. And then there is this triangle. So they both have the correct angle A. They both have the 31 for B. And both of them have a side length of 12 here. The only difference is the angle C and the length of C. I probably shouldn't put congruent marks. This is that size, and maybe let's get rid of that. There you go. So this C and this C are obviously not the same length. This angle and this angle are also not the same length. This is kind of a special sort of scenario. There's a test you can do to see if you have a two-solution triangle. What that test is, are you ready for it? So if you want to see if it's a two-solution triangle, you need to drop, this is called an altitude, and label this thing H. Okay. If it's going to have two solutions, what will be true is that H will be smaller than A, and A will be smaller than B, and angle A must be acute. So these two criteria have to happen. As a side note, the way you would find this angle A, or this length H is equal to, if we look at it as a right triangle, opposite over hypotenuse, this would be sine, so sine of 20.5 over hypotenuse, right? H over B equals sine of A. To get H, you just multiply by B, so times 31. So H equals B sine of capital A. Because I don't want you to have to memorize another formula and then check, oh, is the angle that we got acute, and then is the side across from the angle bigger than this formula but less than that other number we have? This seems needlessly complicated to me for you learning a brand new skill. So I wanted to show it to you just so you're aware that sometimes there are, they're called ambiguous situations where there's two different answers and you can't tell which one they are. Both of them are solutions. I'm going to do my best so that you don't have to mess with these, but just be aware, when you're building bridges and stuff, that this stuff exists. So there we go. If you have questions or you feel like I didn't explain something clearly enough, or you go, you know what, Barton, I'm just not sure. Why did you flip that? Where did you get that number from? How did you decide that there was no solution? If you have any questions like that, feel free to go to the WebEx, walk on over, knock on the door, I'll let you in, and then say, hey, Mr. Barton, could you please clarify this point at 16 minutes and 32 seconds into the video? Can you tell me what you're talking about there? And I'll say, absolutely, anything for you, my favorite student.